What does amplitude and period mean for a sine or cosine graph? Also, would you like to know where knowing about these graphs would be useful? Well, stick around to the end of this video to find out. Are you ready to learn some math? Let's go. To graph the sine function, we'll need to take a look at the unit circle. If you like this particular unit circle, this is something that I made. You can actually find a link to it in the description on Teachers Pay Teachers as well as Amazon Ignite. But let's go ahead and graph the sine function. For each angle, we have a point. So the sine is going to be the y value of that point. So as an example, for 0 radians, the sine would be 0. For pi over 6 radians, the sine is 1/2. For pi over 4 radians, the sine is radical 2 over 2. Let's go ahead and keep filling these values in on the rest of the unit circle. What would this look like if we graphed it? Let's see what that looks like. In order to graph this, let's first decide on the scale. So we're going to say that the x-axis goes by 30. So each line represents 30 degrees. So 30, 60, 90 will make that pi over 2 radians. 30, 60, 90. Instead of 180 degrees, we'll make this pi radians. 30, 60, 90. 270 degrees will be 3 pi over 2, 30, 60, 90, this will be 360 degrees or 2 pi radians. So we'll just reverse everything to get the rest of them, the negative versions we should say. So now for the x-axis, we'll say every 3 represents 1 unit. So we'll make this positive 1, and we'll make this negative 1. So we'll also want to, since we're graphing, we'll also want to approximate these. So we'll say that this is 0.5 for 1/2. And if you put this in the calculator, square root of 2 divided by 2 is about 0.7. And square root of 3 divided by 2 is about 0.8. So we'll go ahead and plot these. So now let's go ahead and connect what we have so far. So far it's going to connect and curve. That's important to remember. When we connect everything, it has to curve. So let's plot the rest of the points. So this is our sine graph. When we look at this graph, we'll notice that there's a portion of it that we can basically copy and paste to make the rest of the graph. And let's try and highlight that. So let's say we looked at this piece here. We can basically keep copying and pasting this piece over and over to make the rest of the graph. This is what we would call the fundamental cycle. And if you notice that it takes this long for that cycle to happen, that's called a period. So in this case, we're going to say that this sine graph, the parent function here, has a period of 2 pi radians because it takes 2 pi for that fundamental cycle to happen. We notice also there's actually a midline. So right in the middle of the maximum and the minimum, there's a line that goes right through the middle. We can call it the midline, but we can also call it something else. We can call it the sinusoidal axis, and for whatever reason, students always chew this word up, sinusoidal axis. Anyway, the sinusoidal axis in this case runs right through 0. So we're going to say y equals 0 is the sinusoidal axis. It won't always be the sinusoidal axis, but in this case it is for the parent function. Alright, what is the amplitude? Well, the amplitude is going to represent a particular distance. So if we took the maximum and we went straight down to that sinusoidal axis and we said, how much is that distance? That's what we're calling the amplitude. In this case, the amplitude is 1. If you notice that when we write this y equals sine x, it's really 1 times sine x. So that amplitude is always going to be the number in front of the sine or cosine function. Notice also that that amplitude is the same distance from the minimum to that maximum value as well. So in this case, we can see in both examples that the amplitude is 1. But what do we mean by phase shift? We'll get into this in a little bit more detail in a future video. But the phase shift basically is how much is it moving left or right compared to the parent function. So if I give you y equals sine of, let's say, x plus 3, then we're moving 3 units to the left. Or if I gave you y equals sine of x minus pi over 2, then we're moving pi over 2 units to the right. So all it is basically a horizontal movement left or right from the parent function. So remember, this is the parent function. I know I wrote it on the transform function line, but this is the parent function. We're talking about the original function, y equals sine x. So our phase shift here, we're going to say that we have none. If you made it this far, congratulations, you are to be commended. And why don't I reward you with an awkward joke today? If you made it this far, hopefully you feel a little bit better about graphing sine functions, and hopefully this isn't you. Now let's get back to some graphing. So let's plot these points. To graph the cosine function, let's decide on a scale. And we'll make it easy. We use exactly the same scale. So 30, 60, 90, 30, 60, 90, 30, 60, 90, and here we go. So that's pi over 2, pi, 3 pi over 2, 2 pi, and just reverse it. So let's plot the points. And we'll reverse the pattern to get the rest of the points. Remember, first of all, again, the way that the unit circle works, this is 0. So we start at 0. And if we're going negative, negative is this direction. So negative pi over 2 is here, negative pi is here, negative 3 pi over 2 is here, and then negative 2 pi puts us back where we started. So if we got our points at negative pi over 2, remember this was our point. At negative pi, this was our point. And so we can get our values. So the cosine is the first number. So we're going to put, let's see here, for negative pi over 2, 0. And for negative pi, we said negative 1. And if we follow this pattern, that's going to give us the rest of our points. So negative 3 pi over 2 would be 0, and negative 2 pi would be 1. And then we can just connect it to get the rest of our graph. Ooh, it looks terrible. Alright, So we know that we have a fundamental cycle here, just like last time. Our fundamental cycle is the part that we can copy and paste to make the rest of our graph. So here's our fundamental cycle. The period is how long it takes for that to happen. So we go from 0 to 2 pi to make that happen. So we're going to say that the period on this one is also 2 pi. We have a line that runs right through the middle of everything. And we're going to call that the sinusoidal axis. So in this case, our sinusoidal axis runs right through 0. So y equals 0 is our sinusoidal axis. Again, the amplitude is the vertical distance between the maximum. So the maximum starts here this time. And the sinusoidal axis. So this distance is our amplitude. It's the same distance from the minimum to that middle line. So this is also the amplitude. So here our amplitude is 1 because that distance is 1. And if you notice that it's the same as the number that we would normally put in the front of the cosine. Our phase shift, we don't need to beat a dead horse. So I know some people don't know that expression, but beat a dead horse. Horse is already dead. So no phase shift is apparent here. And of course, cosine of x minus pi over 2, what kind of phase shift do you suppose that would have? Well, if we had this as our graph, we'd have a phase shift to the right of pi over 2. Hopefully this is how you feel, and if any part of this video was useful for you, please don't forget to hit the subscribe button. That really helps the channel to keep going. Hopefully I can continue to make improvements, continue to make videos that are hopefully helpful and useful and maybe even entertaining if you find my awkward jokes entertaining. In any case, don't forget to hit subscribe. See you next time. Where is all of this important? Well, when we talk about amplitude, period, frequency, phase shift, all of these things are things that come up when we deal with light and sound. And in terms of seeing a practical application of this, I'll link a video in the description that refers to that. It's actually a pretty informative video, as well as I'll try and put a title card here to give some information about that as well.